Dear students, in study of physics, we basically measure physical quantities. The first chapter is based on the uh, measurement of physical quantities and their units, related units. So the physical quantities are of two types, base or fundamental quantities and derived quantities. Base or fundamental quantities are such type of quantities which are direct. That means we cannot derive or we cannot get these quantities from other, such as mass, length, time, current, light, temperature, and amount of substance. These are the 7 fundamental or base quantities. While measurement of any physical quantity involves comparison with a certain basic or internationally accepted reference, and those reference standards are called units. So the units associated with the measurement of a physical quantity, and these units are for fundamental quantities: kilogram for mass, meter for length, second for time, candela for light or luminous intensity, mole for amount of substance, Kelvin for temperature. These are the internationally accepted units, and these units are called base or fundamental units. So, units can also be classified into two types: fundamental or base units and derived units. The units associated with fundamental quantities or base quantities are called fundamental units or base units, and the unit associated with derived quantities are called derived units. So, what are the derived quantities? The quantities that can be obtained by using two or more basic quantities or fundamental quantities are called derived quantities. For example, speed. Speed can be written as distance divided by time. Here, two different physical quantities are used. So, this speed is the derived quantity. Similarly, uh, acceleration is again explained as the change in velocity with respect to time. Here also two quantities are involved. Again, change in velocity can also be defined as the change in displacement with respect to time. So acceleration can be defined as the change in displacement divided by time square. So it is also a derived quantity. That means acceleration is also a derived quantity. So there are different or varied number of derived quantities, and the units associated with this type of quantities are called derived units. The most commonly used system of units are CGS system and MKS system. In CGS system, C stands for centimeter, G for gram, and S for second. So in centimeter is for length, gram is for mass, and S second is for time. So this is one system of unit, that is CGS system, which is widely used, and another system is MKS system or SI system of units. That is, M is for meter, meter is a unit of length, K is for kilogram, that is, it is for mass, and S is for time. So it is MKS system. Here all the 7 units are in SI system of units. Besides these 7 units, there are 2 more units that are defined for plane angle and solid angle. Let us see what are plane angle and solid angle. So let us consider a circle. Let AB is the arc of that circle. Length of the arc is L and R is the radius of the circle. If we cut arc of length L, A, B, then this portion of the circumference of the circle subtends an angle theta at the center of the circle. Again I am repeating, this arc AB subtends an angle theta at the center of the circle. So this angle is called plane angle because circle is a two-dimensional figure. So the angle formed by arc AB at the center is also a plane angle. So this angle can be written as the arc length divided by radius of the circle. So angle theta is equal to arc length by radius of the circle. So this angle is called plane angle, and the unit of this angle, unit of plane angle is radian. In earlier episode I have discussed about radian. So in accordance with the units of the physical quantities, I have included this topic also. So this is subtended units of measurement. So radian is the unit of plane angle. Let us see what is solid angle. Let us draw a sphere. It is a sphere. We all know that a sphere is a three-dimensional object. So this is a sphere of radius r. It may be a sphere or spherical shell also. If we cut a portion of the sphere, surface of the sphere, if we cut this portion of the surface of the sphere, let us see what will be the enlarged figure. So this will be like this. Carved portion of the surface of the sphere. So it will be like this. This portion becomes like this. So this is the portion of the surface of the sphere. This is the curved part. As there is a curved part, obviously there will be a center, okay, which is here. This is the center. So this center comes here. And if we draw or join origin of the sphere to the vertices of the curved portion, then this portion, this curvature also subtends an angle theta at the center, but this time this angle is not a plane angle. This is a circular angle. Okay, that means we can say that this ring forms an angle and the structure will be like just like cone. Okay, this is called solid angle. This is called solid angle. This angle is called solid angle. So the unit of solid angle is steradian. And the angle can be written by omega. In plane angle we represent angle by theta. Here solid angle is represented by omega. So expression for solid angle become area of the curvature. So it is area of the curvature divided by r square, divided by r square. So if we write an solid angle value for small curvature, then it becomes the small value of solid angle divided by small area of the surface of the sphere divided by r square. So this will be the expression of solid angle, and SI unit of solid angle is steradian. So let us see how to derive derived units. We have first considered for speed. Speed is equal to distance by time. We know that unit for distance is meter and time second, it is meter per second. So this is the derived unit. Similarly, for velocity, displacement by time, unit will be same, meter per second. Then for acceleration, acceleration is the change in velocity divided by time. We already have velocity units, so directly put this meter per second by second, it gives us meter per second square. So we can get the unit of acceleration, which is also a derived unit. Similarly, for force, we know that force is the product of mass and acceleration. So unit of mass is kg and for acceleration is meter per second. So SI unit is kg meter per second. We also know that SI unit of force is Newton. So 1 Newton can be written as 1 kg meter per second square. For work, it is force multiplied by displacement. So we will put as a unit of force, then of displacement. Now we have kg meter square per second square. So 1 joule is equal to 1 kg meter per second square. Similarly, we can obtain derived units for different derived quantities.